This question, we see a diagram where we have two blocks that are attached to two ropes X and Y. They hang vertically. That's important because then we're dealing with the weight. The mass of the ropes is negligible. That's good to know. What is the tension in X and in Y? The easiest way to start on these is at the base. And we start at the base. There is no tension there. But if we think back to when we learned about tension itself, there are a large number of molecules inside, and what's holding them together are their bonds and their electrostatic forces. But as we go up, the bonds that are holding, say, this one and this one together have to exert a greater force than the middle one and the bottom one. And that's simply because the bottom one is holding up and supporting fewer molecules than is the middle one, and the middle one's holding up fewer molecules than the top one. So in the end, when we get to Y, if we draw the free body diagram, it is holding up the weight of the 2 Newton block, and that's the tension. And why we know that's the tension is they're equal and opposite because it's not accelerating. Newton's second law says F net equals ma. Acceleration is 0, so the forces must be balanced. And at that point, it's holding up a weight of 2 newtons. So Y has to be 2 newtons. So that takes this one out of play, and it takes this one out of play. We're down to 50-50 just by realizing that. Now when we get to rope X, well, we could replace this block, this 5 Newton block, with a 7 Newton block. It's holding up all of the mass of this and all of the mass of that. And if we draw a free body diagram, we have the weight of the 5 Newton and the 2 Newton, and that is going to be the force of tension. So we need 7 newtons is the tension in X, not 5, so therefore we have choice B.